Greetings and welcome back to my channel. Today I will be working again on the high voltage generator that I had from eBay in the last video, and it was fun but very short-lived. With this transformer here, it didn't last very long, so today I'm going to rebuild it, make it a little bit different and more fun. So come and join me. And here are all the parts that I'm going to need to build my contraption today. So the first problem with the previous design was the tiny little heatsink, which I don't even know where I put it now, causing the transistor, this one here, the D880, overheat, and this transistor is busted now. In fact, if I try to test it with a component tester, it appears as two diodes. So to avoid the same problem, I went super oversized. We've got the transformer that we had in the first place, and it's the same one. I just taped it with some tape around to hold the two pieces of core together. We've got a switch. For a replacement transistor, I've got this was desoldered from some junk as well. It's a 2SD2012 big electrolytic cap, a few high power resistors. Those need to be high power because when I first tested the circuit with just a quarter watt resistors, they started smoking really quickly. And as before, some connectors and a couple of caps. Now we're not going to use all of them. I think I will only use this one, but just in case I'll need a different capacity, I'll explain that in the moment. Just like with the previous one, I'll be mounting this on a piece of board just because it's nice and everything is visible. I will begin by mounting the heatsink more or less like this. Okay, the glue is ready, so let's glue the transformer in place like this. Then let's glue in the transformer just like before. I'm gonna put it right in the middle. The switch, mains, the main power connector, not mains. Then the connectors for the output, the big electrolytic cap over here. And for the resistors, I'm going to make two little holes on this side of the board with just a screwdriver, very thin one, and I'm going to push them in like this into the hole, and that should hold them in place. Maybe I'll add just a dab of hot glue over here. Now there is 3 resistors in here. I could really do with 2, but I didn't have the right value, so I've got two 200 ohm resistors, 3 watts, and I'll put those in series to get 400 ohms. And I've got one 160 ohm, which I will connect later on. I'll show you the schematic, what's the idea behind it. So now they are like this. I just need to bend this a little bit to make the connection like this, and I just need to put a solder blob over here to get it connected. I should probably talk a little bit about the schematic. So this is basically what I'm doing. We will have the input voltage, a big reservoir cap, and then we've got the feedback winding with the primary winding, and the feedback winding will go through an RC circuit over here, which basically does the 200 ohm resistors and a capacitor, which will be 5.6 nanofarad, and then through a 160 ohm resistor into the transistor base, and collector is basically taking in the current going in through the primary coil, and that should give us a nice oscillation. So I've bent the resistors like so. So I've got this is where I can connect the feedback winding over here. That will go through those 2 in series, so effectively 400 ohms, and then I can connect the capacitor across like here, and then I need to mount this somehow, and the transistor. A little bit of heatsink compound, thermal paste. Okay, the transistor is on, and with the 3rd resistor bent like this, I should be able to connect this whole feedback circuit into the base of the transistor, like so. We've got most part of our circuit. So here I've connected the feedback and primary winding to the positive of the capacitor, then the power will go here from the switch, and now I've got the main primary winding has to go to the collector of the transistor, and the wire is too short, so I'm just going to add a piece of copper wire to get it going right. And here I've made all the connections So you can see there's wires going in and from to the switch to the breadboard, and pretty much I've connected everything with just bare copper wire. Now what's left to connect the high voltage output to here, put some electrodes in and apply power. I've got it all connected and the electrodes are here. Will it work? And we've got a Jacob's ladder. If I'm careful and I touch only one of the electrodes, I'm not gonna get a shock because this is isolated. Okay, let's increase the volts a little bit. So let's give it, that's 12 volts. Okay, here is a slightly better view. So let's switch it on. And we've got a beautiful Jacob's ladder. I could look at this for a very long time. So satisfying. When the spark is ignited, it's drawing 1.35 amps at 12 volts. When the spark goes off, it's still the same. The wire gets really hot, and the heatsink is warm-ish, but not a big deal yet. For this to work, the wires over here have to be really straight, and that's not so simple to do, because if the spark finds a more preferred place, like here, there is a little bit of a kink in the wire. Let's see now. There we go. That's a little bit better. Let's maybe try, that's 13, let's try 1 more volt. Thank you very much for watching. Subscribe for more random stuff. I promise my voice will get better. But that's it for this one. So for the time being, take care.